Let's look at sample problem 7.8. Predict which substance in the pair would have the lower vapor pressure and the higher boiling point. Justify your prediction using attractive forces. So pause the video and determine which molecule in each of these three pairs will have the higher boiling point and the lower vapor pressure. So taking a look at our first pair, the first thing that we want to do is we want to determine which attractive forces are present in each molecule. So looking at our first molecule, we notice there's a hydroxyl group here, or this alcohol functional group, which means that this molecule can exhibit hydrogen bonding. The other molecule is an alkane, only carbon-carbon and carbon-hydrogen bonds. So the only intermolecular or attractive force this molecule can exhibit is London. London is a weaker attractive force than hydrogen bonding. Since the first molecule or alcohol listed will have a higher or stronger intermolecular force, it will have the higher boiling point and the lower vapor pressure. In our second pair, we have an alkane and an alkene. Both have 8 carbons, so they will have the similar number of electrons. However, the alkene is in a cis formation, which means it has this kinked little double bond here, and it will not be able to effectively interact with another cis alkene. So the straight chain alkane, or this is octane, will have a stronger intermolecular force. Both of these are going to exhibit London forces since they're only made up of carbon-carbon and carbon-hydrogen bond. So the surface area is going to be important here. So the octane will have the higher boiling point since it will have this stronger intermolecular force and the lower vapor pressure. Our last example is between two compounds, and both of which can hydrogen bond. There's a nitrogen bonded to a hydrogen and an oxygen bonded to a hydrogen. So the difference between the two is oxygen has 2 lone pairs while the nitrogen only has 1. Since the compound that has the oxygen-hydrogen bond will be able to show more hydrogen bonds because of the 2 lone pairs on oxygen rather than the 1 lone pair of nitrogen, the second molecule listed with the oxygen-hydrogen covalent bond will have a stronger intermolecular force and thus a higher boiling point and a lower vapor pressure.